Let's take a look at example 4.7.2 where we talk about probabilities from sampling without replacement. An urn has 3 red marbles and 8 blue marbles in it. Draw 2 marbles one at a time, this time without replacement from the urn. So, reminder, without replacement means you do not put the first ball back before you select the second one. So we're pulling the marble out, looking at it, recording the color, and setting it to the side, and then pulling a new one out. There is a tree diagram in your book for this situation, but I'm going to walk you through how to draw one on your own. I think the one in the book is done top down. I'm going to do mine from the left to the right. It doesn't really matter how you draw your tree diagram as long as the information is there and displayed accurately. So, and it also says the branches are labeled with probabilities instead of frequencies. So I'm going to show you about that too. Okay, so for a tree diagram, we have a starting node, and the first branch of my tree diagram is going to represent the first draw of the marbles. So the first marble that I take out. I can either take out a red marble or a blue marble. The probability of drawing a red marble, if there are 3 red and 8 blue, I have a total of 11 marbles. So 3 reds out of 11 total and 8 blue marbles out of 11 total. So I'm going to label my branches with probabilities. And that helps me realize that I have 3 out of 11 chances of getting red and 8 out of 11 chances of getting blue. Then the second level of branches refers to our second draw. We still are able to get red and blue, but now my probabilities are going to change. Since my first draw was red, I no longer have 3 reds in my urn. I only have 2 reds. And tracking the marbles, I took 1 out in the first branch, so I only have 10 left. So for the second draw, to get a red followed by a red, the probability for the second draw red is 2 out of 10. Because I'm on this red branch, I've already drawn 1 red, and now I'm looking to draw a second red. Given that I drew a red first, to draw a red second, my probability is 2/10. Given that I drew a red first, the probability that I draw blue, the second draw, I have 10 in the jar, just like for the red, except this time all 8 of my blue ones are still in there. Similarly on the blue branch, 10 marbles remain in the jar. If I drew a blue one, all 3 of the red marbles are still in the urn. So my chance of drawing a red after a blue is 3/10. And since I drew a blue on this blue branch, I only have 7 blues remaining. So the idea here is when we're on a particular branch, when we're on the red branch, for example, we're assuming we took a red marble out the first time. Then we write the probabilities associated with drawing that red marble first. What's our second draw? Similarly on the blue branch, I'm assuming I have a blue ball out. What's the probability I drew a red or a blue, given that a blue ball is out? Okay? The next thing to notice, when you're dealing with probabilities on a tree diagram, notice what they add up to. 3 11ths plus 8 11ths is 11 11ths, which is 1. So add them together, they equal 1. Check out this sub-branch. 2/10 plus 8/10, add them together, they equal 1. 3/10 plus 7/10, added together, equals 1. This is not coincidence. This will always happen if your tree diagram is set up correctly. Each level, each sub-branch will add up to 1. Now let's take a look at how to calculate the following probabilities using the tree diagram. The probability of a red followed by a red, we're going to start at the beginning, and we're going to pick up a red and then pick up another red. So to get the probability of 2 reds, we multiply together the probabilities on the branches. So 3/11 for the first red times 2/10 for the second red, which gives us 6 out of 110, 0.0545. Part B, it says fill in the blanks. Probability of red, blue, or blue, red, 3/11 times 8/10 plus what two probabilities? Well, red, blue, so this is red, blue. That's captured by that branch, red and blue, 3/11 times 8/10. And now we're going to look at blue followed by red. So go down the blue branch and then go up to red. And that'll give us 8/11 times 3/10, which gives us a probability of 0.4364, which is indeed 48 out of 110. I like the decimal answer better because I know what 0.43 is. 48 out of 110. How close is it to half? I don't know. It's a little bit easier for me to think about decimal numbers. So I like the decimal answers. Part C, probability of red on the second given a blue on the first. Given a blue on the first means we're going to focus on the blue branch. We know this has happened. We got a blue on the first draw. So what is the probability of the red on the second for this blue situation? It's 3/10. I'm given the information that I got a blue on the first draw, so I know the blue on the first draw happened. The probability that I get a red second has to be 3/10. Part D, fill in the blanks. Probability of red on first, and blue on second is equal to the probability of red then blue, and they give us 2 blanks, which has to equal 24 out of 110. So red on first, that's 3/11. Blue on second is 8/10. 3/11, 8/10, which does indeed equal 24 out of 110. E, find the probability of a blue followed by a blue. Blue and blue. Again, following the blue branch, blue and blue. We're going to multiply those together. 8/11 times 7/10 turns out to be 56 over 110, which is 5091. 5090909. The 09s repeat forever, but we can just end at 5091. And that's our probability for 2 blues. Notice when we're finding an and probability, we're multiplying the 2 branches together. We're multiplying one blue branch times the second blue branch that's adjacent or coming off of that first blue branch. Or in the case of part D, we're multiplying the red on first 3/11 times the blue probability 8/10 on that same branch. When we're talking about a given probability, we only want the second branch probabilities. We're not multiplying them together because we know the first draw has already happened and we already know what that first draw is. So we don't want to consider the probability of the first draw since we know what the first draw is. Take a look at F. Find the probability of blue on the second given red on first. Red on first, we're here. We already drew the red. We had a 3/11 probability of drawing the red, but we know we have a red. Now what's the probability that we draw blue on the second draw? 8/10, or 0.8. So this problem does a really good job of illustrating the difference between and probabilities, where if we have a tree diagram like this, we would multiply the sequences of draws, the sequences of probabilities together to get the and probabilities, and the given probabilities, which means we already know the first draw has happened, so we can move past that probability and go into the second draw probability. So hopefully that helps in the whole realm of given probabilities, these conditionals.